Hey y'all, Data Guy here with a special appearance today from the Data Dog. And today I'm just kind of making actually a quick viewer request follow up to my previous video on optimizing SQL queries, how you can write really efficient, really cost effective SQL queries, to just kind of focus in on one specific area, which is the power of index all strategies in data engineering and query optimization. So index all strategies, to begin with, are really just involve indexing every column of a database, as well as every row, and enabling really rapid data retrieval and enhancing overall query performance because you're only looking for indexes. You don't have to look for the actual values. And what I'm going to explore in this video is really just all the advantages that index all strategies can bring in getting different insights from different sources out there. And then also, because the person that reached out to me was Igor from Rockset, I am going to talk a little bit about their converged indexing approach there and how that can kind of represent, converged indexing is basically index all, where you have everything indexed and you converge and kind of merge those indexes into a converged index, and I'll explain what that is too, to write really well optimized and really efficient SQL queries. So without further ado, let's get into it. So the first reason why I want to talk about index all is its performance capabilities. So big thing that you can do with index all is that and I'll have an example up here, is traditional indexing, and let me switch this to a non-Python file. So here you have kind of an example of traditional indexing, where you just will typically create indexes on selected columns, which can speed up certain queries, but if you don't have an index on every query, some of them are on every column or every row, some are going to be more inefficient. To contrast that, index all strategies ensure that every query benefits from indexed access paths. And so Rockset's converged indexing, just related back to that, combines row, columnar, and search indexes. But in this just more simple example, what you can do is just create an index on every single column that's within your data set. So not just the last name and department, if you know those are the most commonly searched, but on employee ID, on first name, on email, department. Department's already there, but make sure you're having an index on every single column, and that'll really help improve query performance when you're trying to combine different data sets, when you're going down the list of things that you need to pull. Typically, you're not going to be storing it unless you need it at some point, and so just having everything indexed and ready to go means that even for those long tail queries, you'll still have really good performance without creating a massive load on your database, because adding indexes isn't going to cause a whole lot of problems for you. Now, another example and reason why you might want to use index all strategies is for the flexibility and efficiency in handling a wide range of query patterns. So by indexing all columns, these strategies will help eliminate the need for database administrators to try and predict and predefine indexing needs, where you need to relay to whoever your DBA is to say, hey, index these columns, this is what's most often queried. And that can be challenging in dynamic or ad hoc query environments where, hey, I want to upload a new data set, I want it to automatically be indexed, and I want to be able to query it. If you have an index all strategy, every data set that you're bringing in, the database administrator or whoever's running your database, or you can even programmatically manage this and say, hey, any new data set that comes in, given an index, then you immediately have that data available in a really efficient way, or an efficiently indexed way, so that you can execute kind of complex queries on new data sets that have multiple filters, joins, aggregations, whatever you need for whatever use case you're going into. And you can even just see that in a simple example where, hey, the first query, if it doesn't have indexes, is going to run much slower than the second index query, where, hey, now every single column, not just employees, is indexed, and I can quickly and easily access data that, even if I have to have multiple subqueries, I'm using the where clause and getting complex with it. And also, here's just a more complex example of that same strategy, where you can really see, how it's going to speed up these more optimized queries. Where, hey, I have multiple conditions, I'm selecting multiple different fields, and I need to do it from a certain subset. Having an index to really narrow that down and make it easier for the database computer to search for those necessary rows is going to save you a lot of money in the long term. Now, another, maybe a little bit boring, but still really important kind of feature of index all optimization is it results in simplified database management. management of databases becomes very straightforward with index all strategies. If you're applying traditional indexing, that really requires careful planning, maintenance to ensure that the right columns are indexed as query patterns evolve or change. And this process can be pretty time consuming and error prone. However, if you have index all strategies where your index process is completely automated, that number one, reduces the administrative burden and allows DBAs, database administrators, to focus on much more interesting higher level tasks like optimizing database design and ensuring data integrity, and leave just kind of the boilerplate, boring, hey, every day I got to log in and index a new field operations to things that can be super well optimized by automating that, because there's no need to waste someone's time just coming in and indexing every column that arrives in a database, right? Now, the fourth reason why you might want to implement this strategy is for cost-effective scalability. As your data volumes grow, maintaining high query performance is going to become increasingly challenging, and index all strategies support cost-effective scalability by ensuring that your query performance is going to remain consistent regardless of that data size. So by leveraging advanced indexing techniques and efficient storage mechanisms, these strategies can really handle large data sets and allow you to handle them at a really reduced operational cost versus if those indexes were unindexed, or versus the large data sets were unindexed. Sorry, I'm saying a lot of the same words, I'm tripping over myself. And you can see here, another example of that. It's pretty basic again, but just being able to do groupings, counts, have those operations actually take place within the query. Not the best practice, actually, if you watch my SQL query optimization video, but if you have indexed, every column is indexed, then it might not be as computationally extensive as if you had done it without it, but never use functions within your queries. So, these are all really cool, ideas, but I also want to talk about, some of the real world applications and how they demonstrate the effectiveness of index all strategies. For instance, let's say you're running an e-commerce platform where search and filtering queries are really frequent and diverse. Index all strategies can help provide rapid results and enhance your user experience and engagement by running those queries much, much faster than maybe your competitors. When you're running an Amazon query, when you're running any kind of query online, you're effectively doing a database query. And so being able to do them really fast, having index all strategies where, if someone's searching your website, yes, maybe if 99% of your users are going to be searching, all the indexes you have, all the data sets you have indexed, but if you're dealing with 1 million users, even 1% is thousands of people, right? And so having all of your columns indexed just makes it easier for you to capture those long tail queries and still serve efficient query times to your end users without needing to do a lot of personal optimization and say, hey, all right, even though 1% of users are using this, we still have to index this column. Automate it, save yourself a ton of time, save yourself a ton of money, and also just provide a better end user experience to the developer and the end user. So these are all just things you can apply in any query in any database. I also, because this idea was brought to me by someone that works with the Rockset Open Source Project, want to touch a little bit on how Rockset takes us a little bit further with converged indexes. So without further ado, let's get into that. So the way Rockset does storing columns of documents is in a converged index. And so this converged index incorporates aspects of a row-based store, column-based store, and a search index. So you have columnar and search indexes in the same system, and it's built on top of key value store abstraction where each document is going to map to many different key value pairs. And so this might require more overhead, but doesn't actually. It's a big gain from your current kind of approach, where a converged index requires more space on disk, but queries are much faster. So you're trading off storage for CPU, and you're trading off hardware for human time. So humans no longer need to configure indexes, they don't need to rely and wait on slow queries, and the converged index is the most efficient way to organize data in a way that reduces overhead and optimizes your data for query performance. And then point number 2 is that, as any experienced database users know, as you add in more indexes, writes become heavier, and a single document update now needs to update many indexes and cause many random database writes. And then in addition, in traditional storage based on B trees, random writes to the database translate to random writes on storage. So with Rockset, you use LSM trees instead of B trees, and LSM trees are optimized for writes because they turn random writes to database into sequential writes on storage. And so you can use RocksetDB's LSM tree implementation, and then you can benchmark. You can do hundreds of megabytes per second writes in your distributed setting. And so here you have also a custom SQL query optimizer if using Rockset, so they can optimize your queries even more. But just this base level of this kind of converged index is already much, much faster, just at the trade-off of additional storage per row in the database. So I thought this was really interesting. I got a random LinkedIn message, and I wanted to, kind of explore index all, and then also talk about converged index because it kind of makes sense as like the natural endpoint to an index all strategy. So I hope you enjoyed this video. Hope you found it helpful, and I hope you have a great rest of your day. Data Guy out.